So we've gone over Pythagorean theorem, Pythagorean triples, working with right triangles. The next topic that we can segue into, now that we know about right triangles and Pythagorean theorem, is the distance formula. And the distance formula is used to find how far away 2 points are on an xy graph. So if we connected these dots, we want to find the distance between points P and Q. And since this is not like a straight line, well, it is a straight line, but it's not a nice straight line that, goes perfectly across, one of the horizontal lines there. We could just count across and see how many or how long that line is with the distances from end to end. But here we can't do that, right? So we need to figure out a different way to do that. And once you know the distance formula, you can just use it, but I just want to show you where it comes from. So what if we did this? What if we made a triangle, right? What if I put a point right here, and, right here, it looks like we have a right triangle, if we just imagine that there. So again, we're still trying to find the length between P and Q, but we're going to use this right triangle that we've now imagined and illustrated to figure out what that is. And you should already be thinking Pythagorean theorem, right? We're finding the hypotenuse. We're finding the length of the longest side. This is a right triangle. So let's go about it. So the first thing we want to do is we want to figure out how long is each side. So point Q, right, it has xy coordinate of 13.8, and then point P, its x and y coordinates are 1, 3, and then this point that we put down at the beginning of the video is going to be 13.3. If you don't know how to get coordinates from points, I made a video on that, so go back and watch that. But yeah, let's figure out how long this side is. Right? We can count the dots, and we can see that it's 1, 2, 3, 4, 5. So we should get 5. But another way we could get 5 is we could figure out what's the difference. What's the vertical difference between the 2 points? In other words, what's the difference between their y values? Because we're talking about vertical distance. And so we have 8 over here, and then we have 3 down here. And if I subtract those two things, I'll get 5, right? So the length of this leg of the triangle, that segment, is 5. So same thing can be done down here for this other leg, right? We can count across, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. Or we could also figure out what's the difference, what's the horizontal difference between the x values of point P and then that point. Maybe we could name that point too. We could call it R. So again, we could count, or we could say, hey, the difference between point R and point P when it comes to their x values, well, that's going to be 13 and then minus 1, which is going to give us 12, right? So now I could redraw this triangle if I wanted to. We have something that looks like this, right? This is a triangle. And we got a right angle here. This is 5, this is 12, and this is the line that connects points P and Q. We could call it C if we wanted to. Make it really easy. So we want to find C. We want to find the distance between points P and Q. Well, what we can do is let's just write it out using Pythagorean theorem. So if I call we could just start with Pythagorean theorem. Remember, that is a squared plus b squared equals c squared. Well, a squared, we could call that 5 squared. And then plus b squared, right? That's going to be 12 squared, and then is equal to c squared, or we could just call it pq squared, like that. All right, so we're just replacing our a, b, and c with the values and terms that we're working with in this specific problem. So everything should look pretty familiar. Well, we want to find what PQ is. We don't want PQ squared. So how do we undo a square? Well, we take the square root of both sides. So what we'll get is PQ over here. And then on the left side of the equal sign, we'll still have all this stuff in parentheses. So it'll be 5 squared plus 12 squared. And if I just wanted to rearrange this, I could write it like this. So PQ is equal to the square root of 5 squared plus 12 squared. And if we wanted to solve it, right, this would just be equal to the square root of 25 plus 144. Square root of 25 plus 144 is the square root of 169. And the square root of 169 is 13. So the length of PQ, or the distance between those 2 points, is going to be equal to 13. So I'm about to give you the distance formula, but I'm going to use this example just to illustrate again how we get to it. And you'll see it kind of come into itself out of nowhere, I promise. So again, we have PQ is equal to the square root of 5 squared plus 12 squared. Well, how did we get 5 squared? Well, we subtracted. We found the difference between the y values of these 2 points, Q and R. So we did 8 minus 3 squared. And then how did we get 12? Well, we did the same thing, but instead we found the difference between the x values of points P and R. So that's going to be 13 minus 1 squared. So I'm going to put a box around this. And then here's the distance formula. The distance formula, D, is equal to the square root of x2 minus x1 squared plus y2 minus 1 squared. So that sure does look very similar. Let's draw an actual rectangle there. This looks very similar to the one we did above right there. So now we're going to do some examples to drive this point home, and I think it'll make a lot of sense.